I'd like to welcome everyone to the webinar series of the Cybersecurity and Information Systems Information Analysis Center, CSIAC. Today's presentation is entitled DevSecOps Pipeline for Complex Software-Intensive Systems, Addressing Cybersecurity Challenges. My name is Steve Warzala. I'm the CSIAC Outreach Manager. A few administrative notes before we begin. First, all phones have been muted except for the presenters. Questions may be asked at any time during the presentation by utilizing the chat function, and time permitting, your questions will be answered at the end of the session. Today's briefing slides and webinar recording will be posted on our website within a couple of days. Finally, I'd like to take a moment to acknowledge and thank our sponsor, the Defense Technical Information Center, DTIC. The funding that DTIC provides enables CSIAC to conduct these webinars. My pleasure to introduce our presenter for today's webinar, Dr. Carol Woody. Dr. Woody is a principal researcher for the CERT division of the Software Engineering Institute at Carnegie Mellon University. Her research focuses on building capabilities and competencies for measuring, managing, and sustaining cybersecurity for highly complex network systems and systems of systems. Carol has successfully implemented technology solutions for such diverse domains as banking, mining, manufacturing, and finance. The CERT Cybersecurity Engineering and Software Assurance Professional Certificate, released in March 2018, is based on research Carol led. She is also the co-author of the book, Cybersecurity Engineering, A Practical Approach for Systems and Software Assurance. I will now turn the presentation over to Dr. Woody. Good afternoon, Carol. The floor is now yours.
Thank you, Steve. I'm delighted to have this opportunity to share information about one of the research efforts I'm currently supporting. If we can move to my first slide. Thank you. I'm working with a group of CERT researchers who are supporting government customers acquiring complex software-intensive systems and adopting DevSecOps. We discovered that all of us were struggling with similar challenges as these organizations were tackling the integration of cybersecurity and software assurance into a pipeline, essentially to meet the needs of government programs, looking at their compliance points, the challenges they're having in terms of confirming with RMF and other risk needs that they were looking to analyze. We discovered that acquisition and engineering had essentially made choices that improved cost and schedule substantially, but with an unknown impact on cybersecurity and software assurance. It was assumed that the tools that were being used in the pipeline and the automation that was being implemented would handle this. But no mechanisms were structured to either evaluate the pipeline or confirm the product results. Next slide, please. Next slide. When we initially started to share our information, we found that actually all of these programs were tackling multiple changes at the same time. But none of them had developed a shared vision of what all of this change would mean and how it would happen. Different parts of the programs were making choices for various aspects of each one of these shifts that impacted each other, but they were not really collaborating and coordinating. Cost and schedule were the primary drivers, and other qualities were assumed to just be there or be secondary. However, many of these were directly impacted by these choices. We were seeing that roles would have to change, governance would have to change. There was a lot of cross-team collaboration in terms of decision-making that increased exponentially because of these shifts. So we're looking at increased software, we're looking at agile development with DevSecOps, and we're also looking at a movement to shared infrastructure as three of the primary drivers. This lack of shared view, however, left all of the pieces in movement, and no one really had a plan for how all of these would fit together. Each one was being initiated on their own timetable, and each decision was being made at different points in time that we were seeing some very strong uncertainties in terms of the impact, especially on cybersecurity. When we looked at all of these, we figured that we would start with this shift to DevSecOps as our starting point. Because we were really grappling with how do we evaluate a pipeline in terms of its cybersecurity and software assurance. So we chose to focus on a path on how to build this vision. Next slide. Tangentially, there were also new policies and guidance that were being issued. And again, none of this was tied into a vision for the program. So what they were actually doing and how they were approaching it remained unclear. There were opportunities for adaptive acquisition pathways, changes in potential ATO that everyone was anxious to adopt, but no one really knew how. And shifting in terms of some of the nuclear surety issues as well, in terms of some of the discussions for integrating software into that very sensitive and highly concerned area. Each program was building their own path, and it looked like there was an awful lot of synergy that we could capitalize. Next slide, please. What we were seeing, if a program only focused on implementing DevSecOps without critically considering its impact on the other parts of the programs, that they were going to end up with a lot of resulting capability, but there was a real concern about its defensibility and stability. Given the increase of challenges that we've seen in just the last few months with ransomware and supply chain challenges, this was raising major concerns. The programs, as I said earlier, were relying on pipeline tools and automation to find vulnerabilities, and there are limitations to those tools and limitations to the knowledge of how to apply them that looked like they were going to be creating challenges. Compliance may be satisfied by executing the tools, but there is a high rate of false positives that can overwhelm developers if they don't know how to handle these. Of particular concern to us with the operational security was the challenge of specifying controls, but without really understanding the operational risk and the outcomes that were going to be a challenge. We were concerned that we had potential gaps that would represent opportunities for attackers. So the sustainment activities became a real focus for us. And we didn't see anything in the decision-making process that was really looking at this end game, the vision. Next slide. We also didn't see a real understanding of what the adoption of DevSecOps meant. I want to share with you what we have put together as our perspective in this next couple of slides. Adopting a DevSecOps approach is not just setting up tools and automation. The role of the pipeline, how it's structured to meet that role, and the quality of the product it produces has to be carefully considered as an integrated whole. This is a complex collection of parts that are organized to work together based on specific user knowledge and expertise to meet specific needs of an organization. Each pipeline is unique, but ultimately produces the same approach in terms of speeding up the development process. In reality, there are two joined process flows that have to be designed, managed, and used together, and we find fewer thinking in those terms. The first one is a software factory that continuously flows through the plan, develop, build, test, release steps, and then into potentially deliver, deploy, operate, monitor, and feedback as a loop. It uses platforms, tools, and pre-structured controls in place to support this product flow. The second is the integrated pipeline capabilities, which are more than just an infrastructure platform. These are more software, essentially controlling software, and these require the same constant and close administration to ensure that you've got the right tools and controls and access available at all times for the right resources to perform the desired steps in the product flow. So there is a very heavy administration and structuring burden, and the software is essentially controlling the construction of software. Since each pipeline is unique in both the product and the structure, planning for smooth and effective flow at scale, which is what we are seeing these programs needing, is critical. And that planning piece is where our major concern is coming into play for cybersecurity as part of it. Next slide. If we look in a little more depth at the product side, the product should be the factory should be software production and automation continually increasing as the system itself grows and matures. So you've got initial pieces that started and then added functionality and capability that increase the system itself. This should lead also to continually recognizing vulnerabilities and decreasing them in the operational field as you're consistently applying tools that should improve vulnerability removal and reduce vulnerability injection. However, this reality is dependent on trained developers who know how to use the tools and when to apply them. It's based on sprint planning that allows time to not only find but also prioritize and fix the vulnerabilities. Effectiveness will only be known if there is tracking in place to assemble all of the various pieces of information from each of the tools that are being used and the process steps to determine that the remaining vulnerabilities in the product have indeed been reduced. And we are not seeing this focus on monitoring and tracking as part of any standard tool chain right now. Next slide, please. Assembling the materials for the pipeline infrastructure, which is this outer loop that we have, must take into account that none of these building blocks are actually static. Service providers are constantly upgrading their environment to keep the technology, which would be hardware, firmware, and software current, and third-party tools that would be integrated are also continually in need of patching and upgrading to improve functionality and stay current with known vulnerabilities. All of these could potentially represent inherited risks from the supply chain. New and improved tools are also becoming available and may need to be integrated into the pipeline to address new types of vulnerabilities. How will these be made known to the developers? How will the developers be trained in these new tools? And when do they become part of an improved pipeline? If we're doing automation and tying these pieces together for speed. If these new tools find vulnerabilities previously missed, then how do we go back and look at the code that was built previously to improve that? All of these are involved in pieces of planning how the infrastructure supports the product and need to be part of that plan that I was talking about. Next slide. We found that some of the programs we were working with were forgetting that the pipeline is only a portion of the full life cycle for a major program. The pipeline is primarily applied to new development and delivery in those major pieces. And so many were ignoring weaknesses that could be introduced by other parts of the acquisition through code reuse, through third-party software products that were included. All of those are other potential vulnerabilities that need to be thought about in terms of the final product. So total reliance on just the DevSecOps pipeline for all of the cybersecurity and software assurance does not make sense. In every step of the acquisition, there are weaknesses that could be introduced and areas that need to be considered of having potential mission impact. There are other methods such as threat analysis, abuse and misuse case analysis, mission threat analysis, and architecture analysis that are all needed to supplement either before or after what the pipeline is doing, because many of these are working on pieces that then become input to the pipeline. Next slide, please. We think this diagram better describes the complexity of what's being dealt with and what we need to. And planning for how these various pieces integrate is critical if you really want to reap the benefits of the pipeline for the system cybersecurity and software assurance. We have seen a major challenge in the programs in terms of recognizing that these pieces need to be understood and structured in a way that they can be worked together. Because too frequently our organizational structures within a program subdivide these parts to different groups, and many of these groups don't work together. And there are many layers of interdependency that, if you're going to reap the benefits of a pipeline, need to be part of how you're planning the approach. Next slide. The second challenge that I want to emphasize is the high dependency of cybersecurity of the product on the pipeline. So that when you're evaluating the risk of the product, you need to be considering what assumptions have you made about the pipeline, the infrastructure, the shared services, all of these pieces that are working together to provide cybersecurity results. Many of these are parts that programs have limited control over, and they are just components that they are inheriting risk from. The administrators of the pipeline will define how all these parts work together, and they'll be established sequences of processes. All of these need to be looked at in terms of how they contribute or not to the cybersecurity results of the end product. Because of this level of complexity and diversity of participants, we are seeing that there really is no one in charge of monitoring the overall health of the pipeline because the structures are so widely distributed. And by health, I mean the combination of the infrastructure and the product development to actually ensure that there aren't gaps, that the pieces are working smoothly together and are well coordinated. This complexity leaves opportunities for adversaries. And we've certainly seen one of those in our current experience with solar winds coming in through the supply chain. So the risk is real. And what we have been looking at is trying to figure out how do we structure this in a way that we can think about it and plan for it effectively. Next slide. I want to give you a little bit more concrete perspective on the complexity and why it's a concern. If we look at the administration tools, there are a group of them around the pipeline that control many of the interfaces and various aspects of pipeline support. The little diagram in the top right on this slide looks at the interfaces and the parts and pieces that need to work together. And tuning the tools can increase the flow through the pipeline. But this really requires a lot of interrelationships and trust relationships among all of these different pieces. The administrative resources that support the pipeline will now control what each participant can see, and in addition, this goes beyond the typical authentication and authorization roles. So we've increased the administrative level of control, but are the tools performing as expected? This is a presumption that's built on expected behavior, but looking at how do we monitor for these and identify anomalies has not been well structured. The tools are assumed to only perform as expected. As you can see, there's an awful lot of coupling among all of these parts and pieces as the pipeline is being structured. If we move to the next slide, you can see the pieces of these interfaces a little more closely and how tightly they coupled. There's a lot of data that's collected in each one of these steps, but the correlation of it and the comparison of it of expected versus anomaly behavior really is not well structured and has not really been established as a required responsibility. The focus has been on facilitating flow and confirming performance of each defined step. But when we're really looking at the product and the software assurance of that product and the cybersecurity results of that product, we need to understand how all these pieces are working together to address that. Next slide. At an even more granular level, each tool requires specific technical knowledge to administer and use it. The tools are selected to focus on specific development and security needs at each step in the pipeline, and they will be administered by different resources based on their technical expertise. From what we have seen, no one with sufficiency in their depth of knowledge to identify anomalies has sufficient access and responsibility for addressing the security of the overall pipeline. So it's very much of a piecemeal approach that we have been seeing as being implemented based on leveraging existing knowledge. Not an unexpected result, because the expertise to do this is not readily available. And these individuals, in some cases, need very broad knowledge and understanding to even set up the materials and the tools and get them working. But if we're looking at it from a cybersecurity perspective and we're trying to establish how we're going to rely on it, we have to really understand the choices that are made, how these pieces are implemented, and begin to assemble the data that's generated from each one of these pieces to start to put together a perspective of the full activities and the interface trust relationships that are there and monitor them. The speed is not the only thing that we need to be looking at in terms of the pipeline. We really have to understand what are we relying on, and is that trust well placed? Next slide. Here we show even more of the complexity. For each one of the operational processes, they use different components of the pipeline. How these processes are structured, monitored, and maintained will determine the level of oversight that's even feasible. Because of this complexity, the current focus has always been on getting these things to work. But working is only one part of it. We also have to make sure that it's not doing things we don't want it to do. And we're dealing with not only software, but pieces that are tools, scripts, data. All of these are parts of the pipeline infrastructure and parts of the product. In many cases, they're stored in the same places, and access just depends on the role and responsibility of the individual doing the access. So how we look at these and how they're working together becomes a very complex interface, a complex problem. Next slide. Our working group identified that we have this need for understanding and managing the pipeline. But in order to evaluate the pipeline, we basically need a model of how it should operate. And then we can come in and look at a given pipeline and say, is this one meeting expectations? Are there gaps? How can we then evaluate the discrepancies and identify problem areas? So we have chosen to focus on a platform-independent model that we can then apply and show where there are gaps within a given pipeline. The model itself, we are anticipating, would provide a basis then for us to be looking at threats and an attack surface for a specific program. But it would start as where we want it to be as opposed to where it is. And then each program's choices would allow us to evaluate the gaps and determine, are those critical or are they still meeting what the program needs? Next slide. We're developing this reference architecture in a modeling language similar to what we would do if we were modeling a system, because we are thinking about this as a very complex system. And then we can take this architecture and look at a specific instance and compare the ways in which the model is reflected in that specific system or potential gaps. And so what we were on right now is developing the first version of this independent reference model. That's been no small challenge. There are many different perspectives that we're including in it, and then one of the key questions becomes, how detailed should this model be? What we're anticipating is a dual-prong use of this model, one for existing programs that are on DevSecOps, that they can then take this reference model and compare it to the pipeline that they've already set up. But the second usage then too would be to take the reference model itself, tailor it, and then use that as the model to actually build a new pipeline. And both of those purposes we think are viable based on how we're approaching this problem space. Next slide. We're using a model-based engineering methodology specifically because we feel it's been successful in building complex systems. And this is certainly, I hope you understand, based on what I've said so far, a complex system. We have an initial publication, which I've referenced in the slide here, that can provide you with some of the details of what we've done in terms of looking at the challenge area and how we are approaching building the model. Our team is currently assembling the model in using Cameo, but we know this can be readily ported to other frameworks. The model currently includes requirements, capabilities, detailed definitions, because we found that the use of terminology was one of the biggest struggles that we had in terms of even describing a pipeline. So clarity there was critical. And we're also looking at what are the expected processes that need to be part of the pipeline that are important to the cybersecurity aspects of what we need to do. We've also ended up needing to structure capabilities around maturity because organizations, as they're standing up a pipeline, need to understand where do we start, and then how do we then increase the capabilities that we have for cybersecurity and assurance, because these are very complex with roles, responsibilities, and processes, and are not something that you can just add on quickly. They require a lot of planning and structuring and integration. Next slide. One of the things we have identified is that we have to take an enterprise approach. Just looking at the pipeline itself and how it's operating does not provide us sufficient information about, is the pipeline a capable one? Because we are essentially relying on a lot of the organizational capabilities. Are the resources that are being brought in to actually operate this pipeline trained? Are the standards that are being used appropriate to what the product is that the pipeline is producing? Are the trust relationships and the decisions that are being made about that effective based on the governance that the organization has in place and the engineering capabilities? All of those go beyond, in many cases, a single program or a single system. So the enterprise has to be effective at coordinating all of this participation among acquisition, engineering, cybersecurity, and potentially other units. Sometimes this can be done at the program office, but in many cases we're finding that this is beyond just the program. So we're looking at more than a contained environment. We are looking at all of this capability having to be able to be drawn on from the organization. So what we have come up with is the recognition that there is, to a certain extent, a minimum viable enterprise that could even be capable of constructing a DevSecOps approach and implementing it. In some cases, many of these capabilities will even come outside of the enterprise. They will be third party. And so the enterprise itself has to be capable of integrating the supply chain into all of these pieces with the services they're using, the third parties and how they're monitored and managed, how they do their contracting. All of these, again, tie into what is a minimum viable enterprise that can put these pieces together. With each pipeline being unique, we need to know that the needs of the product will be addressed, but we have to be able to draw on a range of capabilities that can then be tied together to produce that product. So we feel that this independent model will start to provide a baseline where we can then come in and start to evaluate at a starting point the model itself, but indirectly the enterprise and how well the enterprise can actually feed what needs to be done and supported by the pipeline. Next slide. So where are we going? As with other components, we have to recognize that cybersecurity and software assurance are not static. So what we need to be able to do is create a DevSecOps pipeline that can not only support the product that needs to be there, but can also be flexible enough to support the changes in the operational environment and the threat pictures that can force changes within the product to deal with this. It's a balancing act. And so we're looking at this model being a starting point for how we begin to understand this balancing act. What are the trade-offs that need to be made among all of the different qualities for a product and a system so that we can have effective operational security? Right now, we see too many programs focusing on just defining a stack of controls that they then layer on top of a system to say, this should protect us. In some cases, they're overprotecting. In some areas, they're underprotecting. And right now, we don't really have a good way of determining how those pieces need to work together. But we think with a model that defines a baseline of how should the cybersecurity work and how should it relate to the pipeline, which we want to rely on for automating these pieces, that we can then begin to evaluate how well we are tying these pieces and parts together and look for gaps where we should be concerned. And not have to look at evaluating each individual control over and over and over. We also will be able to reap the benefits of all of this data that the pipelines themselves collect, so that if we are smart about it, we can then begin to monitor and show that we are improving the output results of the product itself. But that requires good planning and organizing for this data and structures in place to begin to understand it. We know the data part we haven't dug into as much, but we certainly do think that the structures and the pieces and the problem space of beginning to look at how we think about cybersecurity relative to the pipeline is something that we've made a good start on. We're anticipating having a first cut at the model available in the fall, and we hope that this will be something that you will be interested in understanding and potentially helping us to expand and improve. Next slide. This is obviously a work in process, so that we have plenty of room for additional insights. We're working with a subset of programs. I'm sure we haven't identified everything that's needed, but we feel like we've got a good starting point. And so as we move into making this available, which we hope to have in the fall, as I said, we hope this will be something that will be useful to you and will be something that you will be able to provide us feedback on and help us improve it over time. At this point, I'll be happy to handle any questions that will come in, and I thank you for your time.
Well, thank you for that presentation, Carol. That's a excellent work on complex problem, and it's a very important activity that you're undertaking here. So we did get a number of questions in from our attendees. A couple came in regarding software bill of materials, and one was wondering if you and your project included or considered SBOM, And if you could comment on how the software bill of materials deliverable can be managed with the speed and variability of the DevSecOps approach.
We have been looking at SBOM. I've been participating in a lot of the discussions about the standards and how they're emerging. And it looks like it could be a valuable tool going forward. Obviously, we're going to need a lot of buy-in from all of the participants in software development to construct the pieces of SBOM, but then we're also going to need to have tooling that we can put in place within the pipeline that will mine this information and organize it in useful ways that we can then react to it, to understand what is included in the product, to have that help us with understanding the risks that we may have taken on, and also potentially down the road help us better maintain those elements within a system and keep them more current and keep them more up to date, because a lot of hidden pockets of risk come in because people are not aware that they have certain products in their system. But SBOM is, at this point, I think, too much in the starting stages for us to be able to leverage it yet into the pipeline model, but we are certainly keeping an eye on it because we think that has real opportunity going forward.
Thanks. And just to clarify for one of our users, the term is they were asking just what SBOM is, and it's software bill of materials. That's what that is. So we had a question on if you had any thoughts on developing the platform independent model reference architecture using sysml.
As I understand it, what we're doing in Cameo can be ported to sysml with no problem. We have explored porting it to other sources. I'm not working directly with that level of the tool itself, so that's a little outside of my wheelhouse. But my understanding is that we would be able to support that, so it shouldn't be a barrier.
Okay, it might be in the same vein, but there was also a quick question about secure UML. So I don't know if the sysml and the secure UML are kind of in that same level of detail that you were referring to.
Yeah, I'm not an expert on the Cameo at this point, but I would anticipate that's something we could certainly explore as we get the first release of the model ready to make it as accessible as possible.
Okay, great. Thanks, Carol. So there was a question, why not use DODAF or TOGAF or the standard enterprise architecture approach and modify that? A note that FEA2 is a good start as well. And same user also is wondering if this was a digital or paper-based MBSE.
This is a digital environment that we're using entirely, and we found that DODAF doesn't support processes and the interrelationships among the different views as well as Cameo does, because several of us have had experience with using those others. As I understand it, we can export to that tool, but you'll lose some of the interrelationships that we've been able to clearly articulate in the Cameo model. We're not wedded to Cameo as a tool. It was just one that we happen to have. So I wanted to let you folks know that that was one that we had some experience with. So that's the one we went with.
So there was a question following up on that was individuals wondering if BPMN will be used, kind of concurring that the DODAF processes don't work as well either.
I'm not as familiar with that one, so I will have to look into that at a later point in time.
Okay, great, fair enough.
One of my knowledge gaps.
Not a problem. Not a problem. Um, let's see. There was a question. What level of automation do you expect to realize for evaluating PSMs through the lens of the PIM?
I think the level of automation will depend on how well the PSM is structured. I think we can support comparisons very readily because all of our information is structured electronically. Um, and there are capabilities of comparing different parts of the model to each other depending on where you want to do a deep dive. Um, but we found in many cases, those that are actually building the pipeline have not really clearly defined how all the pieces work together. It's more of ad hoc, um, agreed upon steps rather than clearly modeled steps. So I think the comparison piece is going to be dependent on how well the individual PSMs themselves have been structured.
Great, thank you. Um, so an individual was wondering that, considering the amount of data that's being collected by the pipeline, just wondering if your research group has considered utilizing machine learning to help in that process.
We're exploring machine learning with some of the tools that we're actually developing to mine some of this data. But that's more down at the specific data analysis level. We haven't actually seen anything yet that we feel would help us at the modeling stage right now. But certainly, I think as more models are applied, more PSMs exist, there may be ways that we can mine data from those to at least compare to and better understand potential gaps in the PIM. So it's certainly an opportunity going down the road. But I think we have to crawl before we can even walk or run. And I think machine learning is a little ways down the road for us.
Okay, thank you. So earlier in your presentation, when you were talking about the pipeline and introducing, new tools, so an individual was wondering is when you integrate the new tools, does that have a tendency to decrease the productivity of the pipeline for a while as these new tools get incorporated?
Well, I think it depends on what the tools are doing, whether they're part of the direct build process or whether they're more support tools that could be put on the parts that are not directly in the detailed timing. We're actually exploring integrating two new tools that are coming out in the SEI research that are improving secure coding and looking at building a plan for how we would go about integrating those into a pipeline. We've actually identified that there are multiple areas where you can integrate new tools. You can integrate them in your overnight build processes. You can integrate them actually in the developer flow, or you can integrate them in a ancillary process that works on the side but then feeds information back into the developer to help them better improve their product. And all of those have different structures and different constraints on them in terms of what you would do. What we found that is a key part of looking at that tool integration is measurement to be taken before you tie the tool in and then measurement afterwards to ensure that you are making improvements. And those measurements might be in the speed of the pipeline in terms of what is your impact, but what we're also looking at is measurements in terms of the actual final product and the level of risk that it still contains, the vulnerabilities that still remain there. Have we improved, reduced them? So it may be that you may be willing to take a somewhat of a performance hit if your end product has much more improved results and would actually gain you speed in subsequent cycles. So everything's a trade-off. But I think one of the keys is that when you're looking at making a change in the pipeline, you look at it from the standpoint not just of the rate of throughput, but overall, how is this improving the product as well as the pipeline?
And just to follow up on that, we had a couple of comments come in through YouTube, and they were talking about the addressing the cybersecurity in the pipeline and talking about being proactive in that process. The individual made a comment uh, regarding the U.S. auto industry, where they learned that trying to fix the problem at the end of the assembly line wouldn't produce quality. So it's necessary to kind of move those things up front in order to.
Oh, yes.
Yeah. Okay. Like I said, just wanted.
Agreed, absolutely.
Okay. Yeah. Well, like I said, just wanted to, that came in from one of our YouTube viewers, so I just wanted to, get that comment out to the group there.
We actually have documented results around quality improvements that show it's much cheaper to do it earlier. And that, I think, has been fairly consistently documented. But one of the challenges we have is convincing management that they need to do that, because it's an earlier outlay of time and effort that they don't necessarily see in that earlier stage. And so there is this human tendency to try and make each stage you're in as short as possible. But the end result is that you're lengthening the overall product work by putting all of that effort at the end.
Yeah, I think the situation, there's a lot of competing interests and the trade-offs that have to be made. So some people may have one particular goal in mind, but there are other things that really need to be considered, taken into the process as a whole. The big picture, so that
Yeah.
that increases the challenges.
Well, some of that plays into the organizational governance as well, because you have to be recognizing who needs to be participating in the decisions and making sure they are at the table so that you do get a proper perspective on the trade-offs. Too frequently, the decisions are made with a subset of people and you don't have full information around those choices. And you're taking on more risk than you think you are because nobody in the room really understands it.
Yep, yeah, you got to have the right folks involved in that process for sure.
Mm-hmm.
Um, so so there was an individual asking, how do you go from the find and fix vulnerabilities kind of mentality to practices and procedures that develop, trustworthy, high assurance software, without many latent vulnerabilities.
Boy, that's a long leap. Well, you start, I think, by bringing in the tools that you are currently not using and making sure your developers understand how to use them. And I think you will see some immediate improvements of them applying at least a subset of tools. And then from there, increase the sequence of how they're applying the tools and the automated way so that you've got structured processes that they're using so that you can begin to develop repeatability. Because ultimately what you want is consistent products at the back end and not one-offs that, your really good developers do great on these certain pieces, and then your new people develop crap that everybody has to clean up because they're not following a standard structure and everybody's kind of doing their own thing. Transitioning over to knowing what those processes are and then understanding them and growing them for improvement is the key direction there. And that requires leadership and management.
Great, thank you. So there was a question about who do you envision monitoring for security issues for both pipeline and code vulnerabilities? And do traditional security operations teams take this on and learn new tools? Or do you see this being performed in the development teams and interface back to the SecOps teams or both?
I would say that development and engineering needs to take responsibility for the cybersecurity results, because essentially it's their choices, their development approaches, the languages they're using, and the processes they're using that produce the end result. But they also have to be mindful that they need a way of assembling information about what they're doing so that it can be monitored and verified. Because there is knowledge of the threat environment and ways in which the structures and pieces need to be improved constantly to keep up with that, because we're in an arms race in terms of the attack environment and the issues that we're dealing with. And it's that partnership that we are really struggling to establish. We're seeing engineering and development wanting to just run the tools and deal with what the tools tell them and produce an end result. And we're seeing the security people coming in and saying, we want to look at everything we're doing. We can't analyze your stuff early. We've got to see all the parts and pieces together and confirm that you're doing the right controls. Neither one of those approaches is working well, but we need this partnership of producing the pieces that we need, that engineering takes results and takes responsibility for, but they also take responsibility for reporting the results in a way that security can monitor and confirm that they are getting the pieces they're done. Too many systems are built with security coming in at the back end, basically running pen testing and slapping the developers with all of these things they haven't done right. Whereas what we're seeing in reality, the developers want to do things the right way. They want to produce a good product. And so I think the more they understand about how to do that and how to show that they're doing that, the better off we'll all be.
That's great. Thank you, Carol. So we're getting down to the end of the time here for today's webinar, but there were a couple of questions came in regarding the platform independent model that you're developing. Questions about the status. Is there a link to it? How can folks know availability, gain access to it? So if you got to, can share some info on the model itself and how folks might be, able to gain access and use this at some point in time.
I think the best way for me to suggest right now, we have nothing that's going to be releasable until the fall, because we're going to have to go through a lot of internal review steps and mother may I's to have things that we can share more broadly. But you have my email address if you want to send me an email, and we'll put that together and get information out to you as soon as possible.
Okay, that's great. Well, once again, Carol, I want to thank you for taking the time to share your work with us. I think it's important effort that you're undertaking here, very critical. And thanks to our attendees, a lot of great questions today. And I would just like to make a programming note for next month. We're going to be, the topic is going to be on digital twin technology, and that's going to occur on the 13th of July, and that webinar will start at 11 a.m. So if you're interested in that topic, we'll hope to have you join us for that. And with that, once again, Carol, thank you. And everybody, have a great rest of your day. We'll talk to you later. Thank you. Bye-bye now.
Thank you. Bye.